just still live my life either way.
Yes.
What did you eat?
Hey, look up, please. We've done this one together. Right. Now check your notes. Every class did a few, got a little, I don't know, different stopping points. So just make sure we are in the same spot. So we've done this one together. Have we done this one together? Number 5. Okay, start here then. So 5 says the function is square root of x to the 4th plus 5. Write that down. The first step is always the same. Take the derivative of both sides. Step number 2 is I use the square root rule. So the rule says d dx, derivative of, square root of something is equivalent to, or can be rewritten as, 1 over 2 square root of the something, derivative of the something. So that's how I got to step 2. So any questions to there? Anything you see that you're like, wait a minute, I don't see it, I just need help. So from 1 to 2, I look and notice I've got d dx of the square root of something. So I check my rule sheet, and there's a rule that looks just like that, like a perfect match. Remember that on the rule sheet, when you see the parentheses, that's my invention. Telling you that I've combined the square root rule with the chain rule. And the parentheses simply indicate anything. So you customize the rule to whichever problem you're working on. So in this case, the something is the x to the 4th plus 5. So that same something belongs here and also here. Finding derivatives is all about correctly using the equal sign. So what you're doing is you're saying this green box is the same as this green box, which is the same as this green box. Which means I can take away this green box and put this in its place. That's how the rules work.
Which one is that?
Square root rule. So it's right here. 2 points for Hayden for asking. You're good. Please.
So are you putting the same thing in all the parentheses?
Always.
Okay, and how do you know what's supposed to go in there?
So that's a matter of visually matching up the problem you're working on with one of the rules. So what I did, okay, this is just a copy of what's on your blue sheet. But the parentheses can represent any expression. So in my head, I'm thinking, okay, I've got d dx of square root of x to the 4th plus 5. So I know that this green box is now a perfect match with this.
Okay.
Equal means these are the same. So in place of this, I take it away, and I put this in place.
Okay, and then when you're moving from 1 to 2, the d dx of f of x is the same as f prime of x?
Just a different way to write the same thing. 2 points for Rachel. Anyone else? Perfect. So right here, I use the addition property. Splits like this. Questions on line 3 from anyone?
Like, how do you know which properties to use, and like after that, like how do you know when you're completely done? Is my question.
Gotcha. 2 points for Danny. So deciding which property to use is all about making a perfect match with one of the rules on the sheet.
Okay.
So when I look at this one, are you okay from 1 to 2? Okay. So on 2, there's no ddx operator here, so I ignore that. This says ddx of x to the 4th plus 5. So as I scan through the rule sheet, the only rule that matches this situation is the addition rule.
Okay.
So do you, if you don't, just say no, but do you see why the addition rule matches?
I don't.
Okay, so the addition rule says this. Let me get some space here, hold on. So the addition rule states that if you have d over dx, which means derivative, of one expression plus another, okay? Keep in mind the f here is not this f. It's just a temporary symbol for the rule.
Okay.
This is equivalent to, basically instead of trying to take the derivative of two things together, you may split them and take the two derivatives separately. So this becomes ddx of just f plus ddx of just g.
Okay.
You good from,
Yeah. Now that makes
so you're good to 3 now?
Yeah.
Cool. And all you do, Danny, just answering the other question, is you just keep finding a rule that fits. So now I look and say, okay, this no ddx operator, nothing to do. This is ddx of something to a number. So I remember the power rule over here. I erased the word. So the power rule states that, let's see, d of something to a number is the same as number something, number minus 1, derivative of the something. So I'm identifying that this green box here will perfectly match with this green box as long as I declare the something to be x and the exponent to be 4. So now these two match. But the way the rule works is this is only true if everything in parentheses are the same. So this would have to be x, this would have to be x, this would have to be 4, like this. So I use this green box to substitute again, right there. So this gets taken away, this is put in its place. Are you good to there?
Yeah.
Anybody else have questions to this point? Okay, derivative of 5. This says derivative of, remember, derivative means change in y over change in x. So this is y equal 5. Y equal 5 is a function that looks like this. Perfectly flat. Derivative means tangent slope of the function. So the tangent slope of a function that's always flat is just 0. I'll tell you, you still ask, how do you know when to stop? I'll explain that in a second. But does anyone have a question to hear? Like anything bothering you on any of whatever it is? Please, Dan.
Just with the writing, is it multiplying or back on step 2 then just for writing down purposes, is it multiplying in between the
Right here?
one? Yeah.
Perfect. This gets multiplied by whatever this becomes.
Okay.
2 points for Danny. And that's why it was crucial that I put a set of parentheses, because I've got one big factor multiplied by another, but this one factor is going to become two separate terms. But that whole thing must still multiply by this. Rachel, question?
Where does the 0 come from?
So right here, 2 points. It says ddx, which means derivative, And derivative means change in y divided by change in x. So the 5 is really a y value. And what they're really saying is, when they write this, is think of a function whose y value is always 5. So that would look like this. And d dx of that function means identify the tangent slope at any point on that function. So it doesn't matter where I look at the function, the tangent slope is always 0.
Okay.
So the derivative of a constant is always 0, a constant alone. Did that make
Okay,
sense?
yeah.
Please.
So is the last step usually the chain rule because it gets rid of the dx over dx?
2 points for Avery. So the rules I gave you are basic rules from the textbook that combine with the chain rule. So we're actually, on the very first step from here to here, we're using a combination of the square root and chain rule together. And that's the rule I gave you. The next step is just the addition property. That has nothing to do with the chain rule. Then from 3 to 4, we're using the power and chain rule together. And you're right, the dx, that's kind of your indicator that there's nothing left to do. Think of it this way. When you're finding a derivative of a function, the derivative operator is going to first operate on the entire function. So from 1 to 2, what happened was the derivative operator took care of the square root. But then it creates a new problem to be solved. So we've got to work on what was inside the square root. The addition property allows us to split that into 2 separate ones. We work on each of those. Once we've worked on every part of the original function, then we've completely found the derivative. So it always works outside in. So we started with square root, then we had these 2 to work on, we split them apart, we worked on each individual term, now we know we're done. We've worked on everything. Question? Cool. Don't forget that here, you've got one big fraction. The numerator factors are 1, 4, and x cubed. The denominator factors are 2 and the square root. So because everything's factored, these 2 can divide, 4 and 2. Next one. Okay. Eyes up here, everybody look at me. Everybody look up. Aiden, just 1 second. Okay, there's really no new calculus to be taught today. But I do have several more examples we'll go through, mostly because I'm concerned that you might have forgotten something algebraic. But calculus, this is it. There's nothing else to learn to do this sheet, just based on what we've already talked about. So, look at number 7, please. Right there. Oh, sorry. Yeah. Go ahead, Hayden. Good. 2 points for us. Write down number 7, please. You don't need to write any of this unless this is just extra answering questions that people have. So. Step number 1 is again exactly the same as always. Take the derivative of both sides. And then from step 1 to step 2, I'm just using the E rules. step 2 to step 3, I'm using a combination of the constant and power rule together. Make sure you don't accept anything I do. If it doesn't really make sense, just ask. You can talk as much as you want to talk.
Which rule do you use?
So from which step to which one, Dan?
On 2 to 3.
So 2 to 3. This is ddx of 2 multiplied by x to the 5th. So that means I'm going to first pull out the constant. That gets me to here. Then this can be rewritten using the power rule. Like that.
Okay.
And then then at this point I've got 2 multiplied by 5 multiplied by x to the 4th multiplied by 1. So I simply choose to multiply the 2 and the 5 to give it 10.
Is there a reason you rearranged the answer when you wrote it?
Gotcha, 2 points. This is perfectly correct. E to the 2x to the 5th multiplied by 10 multiplied by x to the 4th. If it's the written portion of the AP test, just leave it, it's fine. If it's the multiple choice, they'll probably put it in this order out of tradition, not a rule. So, 2 points for mine. Please.
Wait, so do you really kind of need to do the power rule first to get your constant? Because if you're looking at it, where does the 10 come from?
So right here, I can't use the power rule first because I don't have 2x all to the 5th.
Okay.
I've got 2 multiplied by x to the 5th power. The power rule would require, here's the power rule, that you have something to a number, and here I don't. I have 2 multiplied by something to a number. So I use the constant rule first, which says derivative of constant multiplied by something is equivalent to constant multiplied by derivative. So this becomes this,
Okay.
and then this portion is the power rule.
Okay. Oh.
2 points. You need more time here, just wave at me. Right? Please.
When you use the power rule, how do you always, like, why does it end up with the x over the x? Can you explain that?
Right here. So here's the power rule. You good there?
Yeah.
Okay, the power rule that I created allows you to use any expression you want.
Yeah.
So I'm going to use, in this case, the expression just x.
Okay.
So that means this is x, so is this, so is this.
You can just choose just to put in the x.
Well, the way the rule works is you have to identify, okay, what am I trying to find the derivative of? I'm finding the derivative of ddx of x to the 5th.
Oh, okay.
So that means this parenthesis is x, but this symbol that I'm giving you, parenthesis, means same thing throughout.
Okay.
So this is the same as this is the same as this.
Okay.
2 points? Please.
So for the power rule, when it has that blank, you know, and you put an x, does that never ever include like coefficients?
The only way the coefficient would be included is if you had this, 2 points for Brennan. If it said d of 2x all to the 5th, now in order for the power rule to fit, this would have to be 2x.
Okay, 'cause so it's only applying to the whatever the exponent's applying to.
Right. Here the 5 is only an exponent to the x. So only the x belongs here.
Okay.
Did that make sense?
Yeah.
2 points. Anything else, please?
Sure. So does it matter if you use y prime equals or dy or dx equals if you're writing it out?
It doesn't. I kind of switch back and forth just to remind you that they mean the same thing. You can also do this. Once you've written down dy dx once, you don't have to keep writing it.
Okay.
You can't do this, because that would imply that all of these are equal to y and they are not. But once you declare that this is dy dx, then you're fine. So,
Yeah.
2 points for Trey. There we go. Cool, next one. Anybody need more time here? Oh, please, Avery.
I think I remember like the rule where you like multiply the 2 and the 5 through the 10 and 5. I'm forgetting where that comes from.
So, right here, first thing I do is say this is a constant multiplied by whatever. So the constant rule says you don't need to leave the constant inside the derivative operator.
Right.
So that got me to here.
Yes.
Good. So ignore the 2 for a minute, just think of it by itself. Now we need to work on this. So this requires the power rule. So here's the 2 still. So I bring down the 5, x to the 4th dx dx.
Oh.
Now I've got 1, 2, 3 things multiplied. I choose to, instead of writing 2 times 5, I just write 4.
Okay.
Anybody else? 2 for Avery. Next one. Write down number 8, please. It says y equals natural log of 2x to the 4th. It should feel repetitive. That's the whole point, is that the process is exactly the same. You're just using different rules. So. Step number 1, take the derivative of both sides. Step number 2, use the ln rules. Question. Right here, I note that this is really one big fraction. Numerator factors are 1, 8, x to the 3rd. Denominator fractions are 2 and x to the 4th. So I'm allowed to divide any numerator factors with denominator factors. That gets me to here. So, please, Alex. So this is very similar to, it's actually the exact same process we used here. So here it's d dx of 2x to the 5th. Here it's d dx of 2x to the 4th. So pull out the constant, just like this. That would leave d dx of x to the 4th. So here's the 2. The power rule says you bring down the 4, x to the 4 minus 1. So let's write it over here. We just didn't write the steps, so I felt like you could do that in your head now without writing it all out. Here are the details. Like that. 2 points for Allison. Anyone else? Okay,
I'm so confused on how to get the d over x, like dx over dx.
this one here.
Yeah.
So here's the power rule. Okay with that? So right here, I see d dx of x to the fourth. I want to use the power rule, so I've got to make sure that this green box matches perfectly with this green box. So to make that a perfect match, Hayden, what do I need to put inside the parentheses? Oh, not the 2, that's a mistake. Hold on a second. So the green box I'm referring to is right here.
So just x to the fourth.
The parentheses is actually just x. And then the n is 4. So now I have a perfect match. You get there? Which means the way the rule works is this n is 4, this n is 4, this parenthesis is x, and this parenthesis is also x.
Oh, okay.
You see it now.
Yeah.
2 points. Anyone else? Troubled by anything? Brennan, please.
I was just looking at these rules and just had a question on the constant rule. When it says like d, c, then f of x, is f of x like one thing? Or is like,
So the way the constant rule, let me just do a couple of examples, see if this helps. So what the rule is saying is that if you have d dx of c multiplied by whatever.
okay.
So I used f as the symbol, but really it can be anything.
Yeah, but that's like a kind of one thing.
Yeah.
It's not f and then an x.
No, it's one thing.
You
F
just
of
put
x.
f of x.
Gotcha.
Okay.
Yeah, there you go. Does that answer your question?
Yeah.
2 points. Anyone else? Cool, back to here. Anything else here? Cool, next thing. Okay, don't write anything down, just look at the board. This says y equals negative 5x. Okay, if I asked you to draw a parabola, you would go like this, or you might go like this. So think about what this looks like. Negative 5x. Draw what that looks like. Okay, so you're all kind of doing this, right? Is that fair? Like negative 5x is just this function. Wrong way, sorry, this way. So here's negative 5x. Derivative of a function means tell me the tangent slope of that function at any point. But because this is linear, the slope is the same at every single point. Therefore, the value of the derivative is just negative 5. And you don't need to write the steps. You can just look at that and say, I know the derivative is negative 5. Question? Another way to solve this problem is to use the constant property. This is back to what Brendan said. Just say, hey, I've got d dx of negative 5x. So the negative 5 can come out. Give me negative 5 dx dx. That's 1, so just negative 5. So. Question? Solid? number 11. Y is equal to cosine of 2x to the 4th. Okay, on line 1, you don't have to write this and this. I was just illustrating that they're the same thing. So whichever way you prefer to write is fine. Don't write bold. Questions? I just let you get that copy down, and please ask me about anything. As you're writing it, if you're like, wait a minute, I don't see where this comes from, just ask. So process as you write, don't just write. So. Please.
Should we write the -1 sign, or should we write just negative?
Your choice. The reason I wrote -1 is I've seen a lot of people, if they write negative sign, make a mistake later.
Okay.
The -1 prevents an error. When you write negative signs, sometimes people get in their head that negative sign is, I don't know, they think it's something unique, but it's really -1. Same thing happens if you write this. If I write that as -1e to the x, far fewer people will make mistakes than if I write it as -e to the x. This one has the same problem. So whenever we write -1, we tend to just leave off the 1 and just put a negative. But people make a lot of mistakes with that. So I will often put in the -1 to prevent an error. So you don't have to. 2 points for Danny. Brendan.
So you just had adjusted the order on step 3 to get step 4.
Yes, thank you.
How did you get the or one? Like, very last one.
Oh, down here.
Yeah.
So at this point, I'm noticing that I've got 1, 2, 3, 4 factors. So I can multiply in any order that I choose. And -1 multiplied by 8 can be written simply as -8. Here I'm just emphasizing that there's nothing special about this. Writing it in this way is the same thing. I would never write it this way, but you can. That's all. So.
Because the other one looks less.
Yeah, I don't really like how this looks either, but there's nothing wrong with it.
Okay.
2 points.
You just put that at 8x cubed in front and didn't times the -1.
Correct. I just left the -1 multiplying by the sign. So this is how a multiple choice answer is going to look. Please.
If we're like more comfortable writing like the derivative of f of x rather than like the derivative of y, is it okay that we do that, or would you rather like give us y equal to the derivative of y?
Oh, good question. 2 for Noah. All eyes up there, everybody. Sure, here's this one. If they don't specifically declare this to be the function called f, I wouldn't change it to f unless you tell them that you're going to declare it to be f. So I would have just stuck with dy dx. Good question. I don't have a preference, but you wouldn't want them to, yeah, because if you're working with a problem where there's an f function and a g function, that could be a problem. So, please.
If you go straight from like y to y prime, is that?
Yeah, that'd be okay. So you could do that, just say this is y prime. 2 for Maya. Yeah, please. Yeah.
Will we have to have all these memorized by the test?
Yeah, the AP test doesn't have any reference sheet or anything, so I can't do that either. Otherwise, it doesn't help you. So.
Man, this will be hard.
Yeah, there just isn't any choice but to get these memorized. You have to. So, the homework will help. What I did when I memorized these the first time is, as I'm working on the homework. So I write this down. This doesn't require any rules. I just write that down. When I see this, I'm like, okay, it's got to be the cosine rule. I, at that moment, try to remember the cosine rule. So all eyes on me, look. The way your memory works is you have to force it to go down a certain neural pathway. So I'm thinking, okay, I remember the cosine rule. And at that moment on a piece of scratch paper, I would write down the rule. Like I'd literally write on my scratch paper, okay, let's see. D of cosine of something is -1 sine of the something multiplied by the derivative of the something. Like I say the rule and I write it on the scratch paper, then I grab my blue sheet and check to see if I've done it correctly. The only way to get it memorized is to use the neural pathway, but if you use the pathway while you're doing the homework, it becomes a natural part of your memory. If you just try to memorize them cold, it's not as natural. So that's what I would do.
So memorize it like that instead of trying to memorize what you get from it. Instead.
Yeah, memorize this. You've got to memorize the rule.
Okay.
That this becomes this. If you don't memorize both sides, you'll have trouble.
Okay.
But yeah, you have to get them memorized. There's no option. So. Anybody else? The good news is, Trey, is that in the past 11 years, really, I get that it's a struggle initially, but once they're memorized, people don't seem to have trouble any longer. If we do, I try to only give as much homework as necessary to make sure you're really understanding the ideas. And once you've done that, you're fine. After this test, it just kind of sticks. So, because we don't stop using it. Anybody else?
That's why I stopped.
Yes. Hence the importance. Remember, I tried to, as Hadley said, that the first sheet was on plain paper inside sheet protector to indicate the relative importance. This one is on cardstock in sheet protector to indicate its added level of significance. Yes. The last one I gave you is double-sided cardstock in sheet protector. So. Questions here? Next one. Item 13. So write down number 13, please. Okay, I went trying to find ways to help you write less. I went from 1 to 2 and I used 3 separate rules all simultaneously. So I want to see if you're comfortable with that so it saves on writing. Look here, all eyes on the board. Okay, hands up if you can see which rule I used first, from here to here. Just raise your hand. Just raise your hand if you know. Don't say it, just raise your hand. Who knows what rule gets used first to get from here to here? What is it, Mikkel?
Power and constant.
2 points. I'm actually using a rule prior to that. 2 points for that, though. What's rule that gets used prior to that, Noah?
Additional.
How many knew it? 2 points. Okay. So look at me. Come on. It's really not that bad. The addition rule can be used inside your head quite easily. Because all you have to remember is the derivative of 2 things or 3 things added or subtracted, the derivatives can be done separately. So I just mentally do this derivative followed by this derivative. Then I do exactly what Mikkel said. It's just a combination of the power and constant rules. So I temporarily kind of think of the negative 4 by itself. Power rule means I'm going to bring down the negative 1, multiply by the negative 4. So negative 1 times negative 4 would be positive 4. The x is what's being raised to the exponent. The new power is negative 1 minus 1, which is negative 2. You need me to show? Oh, it's actually over here if you had trouble. So, question?
No.
Please, Dan.
You have to write it out or whatever where you, on the next step, where it's 4 over 1 x and...
Oh, gotcha. You don't. I wanted to make sure that everyone knew that there's this property, right, that says x to the negative 2 over 1 is the same as 1 over x squared. But the 4 has nothing to do with that. So I wanted to make it clear that the 4 is a separate factor.
Okay.
But this step does not need to be written. So.
Okay.
Please.
So is
Budget.
the bottom one, though, the answer going to be on the test?
Right here.
Yeah.
If it's a multiple choice test, they could give the answer in this form. I've seen that happen. I've also seen the answer in this form. There's no way to predict which way they'll go. So you've just got to be comfortable that they're the same thing. Rachel?
Can you just remind
2
me,
for Elijah.
why do we have the x to the negative 1 minus 1?
Right here.
Is that part of the power rule?
Uh-huh.
Okay.
So here's the power rule. 2 for Rachel. Like that.
Yeah. Okay.
Do you see the match? Anyone else? Solid. If it feels boring, that's good, because it's supposed to. In a sense, like once you get the hang of it, it's not anything new. It's just the same thing repeated, using the different rules. Sorry about that, you're good.
And it's okay that we're just writing like y prime instead of dy over dx.
Uh-huh. Yeah, y prime and dy dx are the same thing. So. Question, Haiti?
How do you get like 4 over? Oh,
No worries. 2 point. Don't miss the announcements. I texted this out this morning. Does anyone have any question on these 3 signs?
Can we take the retake earlier than that?
Oh, sure. This is just the last time you can do it. So,
Okay.
so what I've done is I posted 2 prep sessions today, right after. So after my meeting, I have a meeting until 2:30. Then tomorrow I have a prep session early, and then 1 after school, not 2. I've got my son's car is malfunctioning. I need to help him get that repaired. So Wednesday, have 1 in the morning, 1 after school. And that's the final time that you can do a retake practice test. You can do it prior, that's fine, just nobody later than Wednesday after school. Thursday, I will likely be available if you want to come in and take the retake, but I won't be doing a formal prep session. And then Monday, I won't be here Friday. My wife has a surgery I need to help with. And then Monday, I'll have time to come in and do the retake again, but that would be the final day for the retake. So, please.
Can we come in earlier than Monday and retake the actual
Yeah.
test?
Yeah, you can come as early as you want. So it is. I do encourage everyone to do the practice test prior to the retake, just as a safe, no risk, double check that everything's, your understanding. So most people have done very, very well on the practice test. But a few were kind of surprised, like, whoa, how did I get 10 out of 20? I'm like, I don't know, you gotta go figure that out. So cool. Next one. 56. questions? There are really two possible answers to any derivative of the tangent problem. This is correct and could show up on a multiple choice test. This is also correct. Again, no way to predict which form they'll use. Either one is the same.
So like when you do step one, where you like do the tangent rule, like I just chose the first one because it was the first one on my paper, but like so it really doesn't matter.
Really doesn't matter. What I'll end up doing is I just remember that 1 over cosine is the same thing as secant. So 1 over cosine squared is the same thing as secant squared. And I'll just work it out and check the answer and see which one matches. If it's the written portion of the test, it doesn't matter. So. Super Brennan.
As the second.
This one or this one? It really doesn't matter. Yeah. What's important actually, Danny, is that you just remember that either one can show up as a multiple choice answer. So you have to know both. Yeah, 1 over cosine means the same thing as secant, so they will test you on either answer. Like they wouldn't have a multiple choice where both answers are present. Just one of the others. Please. Hold 1 second. Oh. Yeah, hey, look up everybody. What Maya's asking about is this. 2 points for Maya. So you're misremembering something. Whoa, that's big. That'll work. Right here. The 3 doesn't distribute. Because these, well, here's what I do. Look, I've seen people have a lot of trouble with an exponent. So I never ever say that the exponent distributes. It just, all that does is cause trouble. So what I do is I remember what cubing means. To cube something means to multiply it by itself 3 times. And yes, because these two things are added, I don't want to do that. That's not fun to go this times this times this. So no, you'll just start with the power rule. It's very similar. I'll let you look back at your example, but it's very similar to this one we did originally. It's almost the exact same problems. Cool. I think we're good. The assignment is to do 1 through 32. And we've done a good portion of those already, so don't redo the ones we've done, but 1 through 32 is the homework. And we will not have any more homework from this sheet. So I only went to 32 because the rest of them seem just repetitive, like we're just doing the same thing again. So I didn't really feel like I wanted to make it too repetitive. But there is extra practice if you do this.
Yes, if we do feel like
Oh yeah, totally. Because the answers are all there, Soraya. So if there's one that for whatever reason you're like, I think I've got it, but I'm not sure, you can just go try another word. So.
Hey.
If anyone has more extra credit that you want to give me, either in the form of pebbles or tickets to apply to term 1, you can basically you can give that to me now if you're ready to turn all that in. Try not to turn in stuff more than once, that just kind of delays things. But if you're like, hey, I've got all I need to get an A or whatever, you can turn that in now. Or you can like stop by at lunch or something. So. Yeah, that's what he's doing. Like I've been showing all the steps to make sure when you didn't get lost. So let me just check you.
Wow.
My great grandma died like a month ago. Great grandma horses.
Looks so joyous.
I will
So happy.
How do you do this? How do you do it? You're doing it on the I get you. Yes. I just chose.
So I asked her, right?
That's that, yeah. Yeah, I know.
Because I have a 1200 he's like, yeah, so I was got like academic leadership class
No, but it literally is literally like from heaven. Because now we have those proposals.
I guess anything to make her about 15.
Yeah. So
What can I do with the night leadership stuff.
it's just prolonged. I really hate that. They're terrible. You're the one who opened my eyes. Complex needs. I know, we're both like, what is this? Not waving, but drowning.
I asked her about this.
With Christian. Ellie, I should do my satisfying abs, didn't I? I'm so happy. It took me 2 hours yesterday to like search.
Oh, wait.
I actually really like them. I really it's these. And look, this is where they are. So if you like really like the one, fun, or like that with the fun, you have what I want to write. Yes. Every single time I get down to read, I'd flip it over and I'd read by stories and then I would read a little bit and then I'd flip it back. And half the time I didn't know until Kel was like, oh, remember this? And I was like, oh, and then go back. Maybe, I don't know. Even you can tell that these 2 parts.
She's like,
No, I know.
all of my English 2 girls are either like